In this video, we are going to cover PyTorch neural network classification problem. And first, we will discuss the architecture of the neural network based upon PyTorch IDE. Then we will discuss the classification problem, which involves predicting whether something is one or another thing. So what we are going to cover in this lecture, we are going to cover the architecture of classification neural network, and then how to make classification data and get it ready. Then we will see the basic functions of input output shapes of TensorFlow and the PyTorch predefined value. Turn the defined data into tensor and create train and test splits. We are going to build a model, neural network models, and set up loss functions and optimizer there. After that, we will going to train the model for get the better accuracy and the validation. Now we are going to build a training and testing loop and then make prediction and evaluate our model. So let's start from the basic library, that is import torch. Then we are going to import the basic data set. So for that I'll use sklearn dot data sets. I'm going to import make circles. All right, so this is the data set which I'm going to import from my sklearn data set. It's a kind of library, you can say. So I'm going to create n samples. Let's say I'm having 1000 samples in order to train, test and validate my neural network. For that I'm using x comma y, two variables, in order to create circles, and it's having function make circles circles circles, and first I'll pass the number of samples and then noise is equal to 0.03. So I want to add little bit of noise in the dots in the data set, and then I'll want to keep my random states as fixed. So for that I'll use some random value, let's say 35, in order to keep my random state so that we can get the same value every time. So I just hit run. You can see no error is found there, so we can have the certain values. So in order to print the like the respective value of x, I'll use indexing here. So it's having x and then x colon 5, and then I'll print that. You can see it's having simply different functions. So 7 4 6 and so on. Similarly I'll print the y colon 5. It's having different functions. All right, so it's having arbitrary values or different values. Okay, so let's change the value of 42. Let's see what will be the relevant value. It's 5 and it's again 0. So you can see we will find 0 here in case of 42 there, and your basic class value is different, is changed now. So this is first 5 labels and we are going to create the other labels. So we can have like another visualization to put together in the pandas data frame. So for that, in order to create the data frame of the circle data, we are going to import pandas library as pd, and then circles, then create circles with pd dot data frame, and then have the round bracket and the curly braces. Then let's say x1. So what's the x1 here? That's a colon. And what's the x here? That's the certain value, and then comma, then the first rows. All right. So after this square bracket, I'm having comma, and then I'll use second x2. So let's say x2, second feature of my data set. So x2 is having different data set. It's having different index number, x square bracket colon and the second column. All right. So after this square bracket, I'm having labels. So, or you can say the your target value. So that is going to represented by y. So this is how I'm going to print the circle value, the my entire data set. So circles dot head, I'm going to create circles dot head, let's say 5. Okay, so scicls is my function name. So I'll make it circles and circles head 5. This is first few 5. You can see on the basis of x1 and x2, I'm having this label. On the basis of these two parameters, these two features, I'm having this label. This is my class, and you can see it's a binary value, 0 and 1. Why so? Because we are having y as the circle and x as the having the simple features value. All right, then we will create the further means binary classification, and you can have that problem is binary classification since there is only two options, O and 1. So if you want to count the values, how many functions, so I'll use circles. What's the function variable name? That is circle dot label. Then I'll use value underscore counts and parenthesis. So label value underscore counts, label, okay, circles. Okay, so data frame at label. Okay, so it's capital L, LABLE, LABLE, and then value counts. So make sure you are writing the correct spelling of your feature value. So 1 is 500, 0 is 500 in a count value. So by default data type is integer 64, and 500 each is quite balanced one, and we don't have bias data set here, so we don't need to perform the another kind of data pre-processing. So first we perform mplot import matplotlib and then pyplot splt. So I'm going to import the second library function, and then with the plt function I'm going to use scatter plot, and for that x is equal to x, that is the feature value, colon comma 0 comma enter, y is equal to x comma and then 1, and then what is the third parameter? C is equal to y, that is the target value, and then we can have C map is equal to plt dot cm dot rd red, yellow, and bu. All right, so this is predefined functions name, and I'm going to hit enter. All right, so you can see this is the nature of my data set, and along the x-axis and y-axis we have got the basic architecture. Now we are going to create that like this one. Get ready, and then we are going to create input to my data set. All right. So how to get the input and output shapes? One of the most common error in the deep learning is shape errors. We just get the wrong dimensions. If your data shapes is mismatched in the tensors, then your operation won't go ahead. If you are having thousands of throughout the particular training and testing data set, you won't find the correct output as well. And for this we are having the certain values. So let's check what is the shape of my entire data set. So for this we are having x shape and y dot shape. All right, so it's capital X, not the small x. So we have 1000 comma 100. So it's a 2 dimension, it's a 1 dimension again. So we have got match on the first dimension, so that's correct. So that's the second dimension x. So we have second dimension, and we have helps to view the values and shapes of single sample. So what about the features and labels? You must have the basic architecture, right? So you will understand what input and output shapes you will be getting there. So let's say we are having x sample and having x sample with the first feature, and we are having y sample as the y second feature. All right, then we are going to values of like x sample and this is small in my case, and then y sample. All right, we are also going to print C V at the shape of the respective variable y sample dot shape. All right, so this is the array, and this is the particular one sample of my data set. All right, so this is 1, so y sample is 1, and x sample is 1, y sample is 2, right? The same for y, and x is 2 comma 1, right? So this second dimension of x means it has 2 features, whereas y has a single features. All right, so now we are going to turn the second part of our this one, where we are going to turn data into tensors. All right, so because we are going to convert into the tensor flow, and we have investigated the inputs and output shapes, and we are going to turn this data set into tensors. Now we are going to import torch. We have already import. If you have not imported, you can import here also. So then we are going to x is equal to torch dot from underscore numpy, give the parenthesis x dot type, and then torch dot float. All right, so this is how we just convert the torch from numpy. So turn data into tensors. This causes issues with computation ahead. Then similarly we are going to copy this line and just change with capital X to y, and then small torch dot float. So I'm going to display the first 5 value of my data set, and then y colon second value. You can see here I'm having tensor. As of now we have received the tensor input and the tensor output. Previously it was array, simply array, but now we are having tensor inputs and tensor output as the training and testing data set. Now we will convert this data set into the input values. So for that we are going to sklearn dot model underscore selection. We are going to import train underscore test underscore split. Then we are going to partition this x train. I'm going to keep x as a caps lock, x train comma x underscore test, and then y underscore train, and then y underscore test, and just give to the define train test and split function. Inside this function we have so many parameters. The first parameter we have x itself, that's our tensor value, feature value. Second value we have the output function. Third we have test underscore size, that's the test partition. If you want to keep 20% as a test data, so you will have to keep 0.2. If you want to keep 30% as a test size, you can have 0.3 here. Then if you want to keep the randoms data as a fix, then you can have the random size, so that you can have the same split every time. After this we are going to check length of our x underscore train, then length of y, so x underscore test, then length of y underscore train, then length of fourth variable, that is y underscore test. I'm going to run that. You can see 1000 rows are divided into 800, 200, 800 and 200 now. So this is the training and testing samples, and we have just converted into the different portions. So now we are going to convert to build a model. So this is going to convert the model into the TensorFlow. All right. So we have end dot module for loss function optimization, creating a training loop. We have a certain PyTorch functions. So for this we have already seen that from torch you can import NN neural network. So that is the agnostic code you can have, right? So I'm going to import that first. So you can, your device is set up is performing GPU or CPU. By default it is CPU. You can convert into CUDA and perform the second device model. You can change the device model. So for the subclasses we have an in module, almost PyTorch module are subclasses of a module. We have linear in order to create the layers in the constructor and capable of handling the inputs and output shapes x and y. We have forward. For the forward class we have forward architecture, and we have method containing forward pass computation and the model, right? So for this what we are going to create, we are going to create a class for constructing our model and the subclass accordingly. So for this model we are going to have circle model v0. So that's the first model, and we are going to import model and then dot model there, and then dot module there. All right. So inside the and dot circle model version 0, we are having and dot module. Then the first definition we are having in it and then you are going to perform the self here and then hit enter. So the first function you can have like super and then dot underscore underscore init underscore underscore, and then again we are going to create that. So in the second we are going to create neural network layers that is capable of handling means different x and y inputs and the certain functions like. So what we are going to create, we are going to create self dot layer. So this is layer 1. We are having layer 1 is equal to nn dot layer, so nn dot linear. Here we are going to create linear architecture. So for this we are having in feature. So what are the in features, like input features? So we are having two inputs, and then what is the out features? So for the output features we are having let's say out FETURS. So this is again S. We are having 5 values. All right. The second line will consist self dot layer, and we are going to create the second layer and then nn dot linear, and the input feature is features TURES is consisting 5. So that's the 5 features. That's the output of the previous layer will be input of the next layer. Therefore we are having inputs as a 5 here, and then we are having output feature is equal to 1, because finally we are getting the one output, that is 0 and 1. All right. So the second we are going to create the function define the forward value, the forward function, that is the method containing the forward pass computation. For this we will have two parameters, self comma x, and then define the return, and we are going to create self dot layer underscore 2, and then we are going to perform self dot layer underscore 1, and then have x inside this function. Right, once we have finished it all these functions, we are going to assign model 0, and we are going to copy this class name, paste it here, and then we are going to create control 2 device. All right, then we are going to print model underscore 0. So I'm going to print this. All right, so this is not done because we have not defined that model here. So what I will do here, from the PyTorch I'll define device is equal to CUDA. If my processor allows CUDA processor, so I'll assign CUDA there, else I'll perform torch.CUDA, that's my processor name, and is available. If it is available, then I'll write underscore AVAILABLE available, and then give the round bracket, and else if it was not available, then I'll write CPU. So by default it will have CPU, and just hit enter to check which device we have. So we have CPU as of now. So if you have CUDA, so obviously the output will be CUDA here. If you have not set up the NVIDIA or any other GPU or TPU data device, so you will have by default CPU there. Accordingly, I'll run this code and you can see get unexpected out features. All right. So out features. Okay. Cut C and cut V and hit enter. So the spelling is again wrong. It's a model. All right. So you can see now, don't find any error in here as of now, which means my model circle model has been created with linear in feature 2 output 5 and the in feature 5 output 1. So this is enough for this lecture. In the next lecture we will cover how to set up loss function and optimizer for the given setup for the given neural network. Thank you.